Okay, so this is lesson 3.6, and the purpose of this video is to explain solving systems of equations that have 3 variables instead of 2. So I'm going to start off with this example, and we're going to do elimination. And the strategy is you want to eliminate one variable at a time, and you're going to do it the same way that you did with 2 equations. So with 2 equations with elimination, we got one of the variables to have the opposite coefficient of the other variable, and then when we added the 2 equations together, that variable went away. It was eliminated. So I'm going to demonstrate that on this problem by adding these 2 equations together. The y's are going to cancel out because the coefficient is already the opposite of each other on the 2 y's. So let's add those 2 equations, and I'm going to get 2x plus 3x gives me 5x, so I'm going to add those 2 over here. And that gives me 5x. Positive y minus y goes away. Negative z plus 2z gives me plus 1z. And that's equal to 5 plus negative 1 is 4. So now we have one equation that has 2 variables, and this is similar to what we've had before. What we need is 2 equations that have the same 2 variables. So we need to eliminate y from another equation. And what I'm going to do is I'm going to take this and this, and I'm going to add those 2 together now. So I'm adding 2x plus y minus z equals 5. And I'm adding the bottom equation, x minus y minus z equals 0. I picked these 2 because, again, the y's have opposite coefficients of each other, and I don't have to do anything to get rid of, to set it up. So if I add these 2 together, I get 3x, the y's go away, I get minus 2z, and I get equals 5. So I'm going to take that, this is my second equation. Now I have 2 equations with 2 variables, so I can solve those. I'm going to solve these by elimination also. So now this is like the type of problem that we had a few lessons ago. Right now it looks like it's going to be easier to get rid of the z, because if I multiply this top equation by 2, which I'm just going to go ahead and write that. Let me get rid of those 2 dashes. Let's multiply everything by 2, and I'm going to write it down here. That gives me 10x plus 2z equals 8. Now the nice thing about this is when I add these 2 together, the z's are eliminated because 2 plus negative 2 is 0. And then I get 13x equals 13, which leaves me with x equals 1. So now I have solved for the x portion. Now I got to find out what z is. I'm going to plug this x equals 1 back up into either of these 2 equations. I'll just use this one. So 3x minus 2z equals 5. So 3 times 1 minus 2z equals 5, which gives me 3 minus 2z equals 5. If I subtract 3 from both sides, I get minus 2z is equal to 2. Divide by negative 2, and I get z equals negative 1. So now I've solved for my x and z portion. I plug both of these back into any of these 3 equations, and I can figure out what y is. I'm going to use the bottom one because it's the easiest. So x is 1, y is what we're looking for, z is negative 1, and this should all add up to give me 0. So that's the same thing as saying 1 minus y plus 1 equals 0. Negative times a negative is a positive. Combine like terms. Now I have negative y plus 2 equals 0, which means, let's get some more space on here, which means negative y equals negative 2 or y equals positive 2. So that's my solution. X equals 1, y equals 2, z equals negative 1. I can write it like this. 1, 2, negative 1. You always write it in alphabetical order. X, Y, Z. 1, 2, negative 1. Okay, well let's check and make sure that 1, 2, negative 1 actually works as a solution. 1, 2, negative 1. I'm going to plug it into these top 2 and make sure it works here. We've already seen that it works in this last equation, but I'm going to pick one of the other ones and try it. 2 times x plus y minus z should equal 5. That gives me 2 plus 1 equals 5. It works. Let's see if 1 to negative 1 is a solution to the second one. 3 times 1, minus y plus 2 times z should equal negative 1. So 3 minus 2 plus negative 2 should equal negative 1, which is same thing as 1 minus 2 should equal negative 1. If I combine these, I get 1. And 1 minus 2 does equal negative 1. So this is our solution. It works. Okay, I want you to go ahead and pause the video and try and solve this problem. Okay, now I'm going to work out this problem and maybe we'll get the same answers. So I got to pick a variable to eliminate first, and I want to eliminate it twice so that I get two equations that don't have that variable. So I'm going to pick z because if I add these two bottom equations together, it gets rid of z, and then all I have to do is multiply this equation by 2, and then I can add it to this equation and get rid of z. So let's go ahead and do that. So if I add these two together, I get 16x plus 10y equals 28. Now I'm going to multiply this equation by 2, this one right here, and that gives me 4x plus 2y minus 2z equals 10. And now I'm going to add it to this middle equation. The z's cancel out again, and so I get 5x plus 6y equals 26. So 5x plus 6y equals 26. Alright, let's get rid of this stuff. Alright, now I have two equations and two variables. I need to get rid of either x or y. In either case, it's kind of complicated, but I think this one's going to be a little bit easier. So the first place that 6 and 10 intersect, the greatest or the least common multiple of those two numbers is going to be 30. So I need to multiply this equation by 3, and that gives me 48x plus 30y equals 3 times 28 is 84. Now I need to get this to 30 also, so I multiply it by 5, and I get 25x. I need to multiply it by negative 5 because I want them to be opposites. Minus 30y is equal to negative 5 times 25 is 125, plus 1 more 5 is 130. So this is negative 130. Okay, so now I have succeeded in getting one of the variables to have the opposite coefficient. You could have done it for x and you could get the correct answer also. So I'm going to add these two together, and that's going to give me 23x is equal to, that's going to be 16 and 30, negative 46. Divide both sides by 23, and I get x is equal to negative 2. So there's the x value. Now I'm going to plug it back into one of these equations to figure out z. I'm going to go ahead and pick this one because the coefficients are smaller. So 5 times x plus 6 times y is equal to 26, and I've substituted in the value for x. Negative 10 plus 6y equals 26. So then that's the same thing as saying 6y is equal to 36 if I add 10 to both sides, and that means y is equal to 6. So now I've got my x and my y values. Let's go ahead and erase this stuff because I need more space. And I'm going to plug these back into one of my equations up here to find z. I'm just going to plug it into the first one. 2 times x plus y minus z is equal to 5. So that's negative 4 plus 6 minus z equals 5, which is 2 minus z equals 5, which means negative z is equal to 3, or z is equal to a negative 3. So here are my values. Negative 2, 6, negative 3. Remember, write x, y, z. Now let's see if this works in the other two equations. So let's check our work. X plus 4y, I'm checking this second equation, plus 2 times z should give me 16. That's negative 2 plus 24 minus 6 should be 16. Negative 2 plus 24 is 22. 22 minus 6 does equal 16. So it works in the second equation. Let's try in this. Oh, I forgot what the solution was. Negative 2, 6, negative 3. Negative 2, 6, negative 3. So I plugged in x, y, and z. Negative 2, 6, negative 3. And this should be equal to 12, the left side. So negative 30 plus 36 plus 6 should equal 12. Negative 30 plus 36 is equal to 6. And 6 plus 6 does equal 12. So it works in all three equations. And this is our solution. Okay. I'm going to go ahead and skip this one and move on to... Actually, you know what? I'm going to use this one to talk about substitution. So you can solve these problems by substitution also. I personally think elimination is easier. Other people think that substitution is easier. So you can kind of take your pick. I'm going to use this equation right here to solve for one of the variables. I'm going to solve for x because it's the easiest one to solve for since its coefficient is 1. So let's go ahead and solve for x. If you have x plus 4y minus 5z equals negative 7, if you subtract 4y from both sides, you get x minus 5z is equal to negative 7 minus 4y. And then if you add 5z to both sides, you get x is equal to negative 7 minus 4y plus 5z. Alright, and the reason why it's nice to solve for x is because now you can substitute x in to the other two equations. Or any two equations actually, but the other two will make it easier. So 3 times x, which is equal to negative 7 minus 4y plus 5z. So that's 3x. Let me do some highlighting here so it's easier to tell what. So I just substituted, that's a very big highlighter. I just substituted in for x all of this value because x is equal to all of that. And then I'm going to copy down the rest. Plus 2y from here. Plus 3z equals 7. Alright, and then I can simplify this. And I will have negative 21 minus 12y, I'm distributing the 3, plus 15z plus 2y plus 3z equals 7. So all this just stayed the same again. So now I'm going to combine like terms to get my y's together, and I'll get negative 10y. Combine like terms to get my z's together, plus 18z. And then I'm going to move this to the other side by adding 21 to both sides. Is equal to 28. So now, using substitution, I've got this down to one equation with two variables. I could substitute x in here and solve it down, and I would have another equation with two variables, and I could proceed from there. I think this is a little bit more difficult, so I'll leave the rest of that as an exercise for you, and I'll just go ahead and show you what the answer is. So if you want to pause the video and try it, I'm going to pause for... Okay, so if you did work out this problem, this is the solution that you should have got. 2, negative 1, 1. I'll plug it into this last equation so that we can see that it works. So I just substituted the values in, and let's solve this numerical expression. 4 plus negative 1 is 3. 3 plus 5 is in fact 8. So you can see that this is the solution. You can get it by substitution or elimination. I said I think elimination is easier, and that's true sometimes, but sometimes substitution is easier. Let me give you an example of when substitution would be easier. Let's say you had something like this. X plus 2y plus 3z equals 6. Y plus 2z equals 0, and z equals 2. If you've already got one of the variables solved here, you might as well just go ahead and substitute it in to the other two equations. So here I got x plus 2y plus 3z, which is 2, because z is equal to 2. And then here's my second equation, y plus 2z, which is 2. And then you see here, now I can just solve this equation. Y plus 4 equals 0. That means y equals negative 4. I can substitute in y equals negative 4 right here. And then I solve this equation. The 6's are going to cancel out, and this is 0 if I subtract 6 from both sides. And so I've got x minus 8 equals 0, so x equals 8. So x equals 8, y equals negative 4, z equals 2. Okay, when one of the variables is solved for you, it's a very quick problem. Alright, let's do one word problem, and then we'll be done with this lesson. Okay, so a company placed $1 million in 3 different accounts. It placed part in short-term notes paying 4.5% interest per year, twice as much in government bonds paying 5%, and the rest in utility bonds paying 4%. The income after 1 year was $45,500. How much did the company place in each account? Okay, so you've got several different equations here. You've got some amount. We'll call accounts. I'll call them account 1 plus account 2 plus account 3. Your different accounts total have $1 million. Okay, so you put three. You had 3 accounts, $1 million total. Short-term notes. Actually, let's use better variables. So we've got short-term notes, government bonds, and utility bonds. So I'll say short-term plus government bonds plus utility bonds is equal to $1 million. Short-term notes pays 0.045 or 4.5% interest. That's your short-term. This is an S and that's a 5. Government bonds pay 5%. And utility bonds pay 4%. And when you add all of that up, your income for 1 year was $45,500. So this equation will give you your income. And then the last equation, since you have 3 variables, you need 3 equations. Just like when we had 2 variables, we needed 2 equations to solve it. It tells you it placed in short-term bonds some amount. It paid twice as much in government bonds and the rest in utility bonds. So we know that whatever is in the short-term amount, if you multiply that by 2, you'll have the amount that's in government bonds. Twice as much was in the short-term as in, twice as much was in the government bonds as the short-term. So if you placed 100,000 in short term, you placed 200,000 in government bonds. Okay, so now we have our 3 equations with 3 different variables, and we can solve this. So I want you to pause the video and try and solve it. And I'm going to go ahead and solve it. So I think substitution is easier in this case because we've already solved for G. So I'm going to substitute 2s everywhere there's a G. So I'm going to use my eraser, and I'm going to put 2s where that G was. And actually, you know what? I'm going to do it in a different color. Blue. 2s. This is what I'm doing substitution with. And then over here, I'm going to replace this G with 2s. 0.05 times 2s. Okay, so now I have 2 equations that only have 2 variables. They have s's and they have u's in them. So now I'm going to erase this to give me some more space, and I'm going to simplify these 2 equations. So I'll go back to black. S plus 2s is 3s. So 3s plus u is equal to 1 million. It's a lot of zeros. 0.045s plus 0.05 times 2s. 0.05 times 2 is 0.1. So if I add 0.045 and 0.1, I get 0.145. So 0.145 45s plus 0.04u is equal to 45,500. So now you have 2 equations and 2 variables. I'm I'm going to erase this stuff above, and I'm going to move this up so that I can have some space to solve. Okay, so now I need to get rid of the u or the 3. So again, I'm going to use substitution because in this case, I don't want to play around with coefficients when I got 0.145 and 0.07. So I'm going to take this top equation, I'm going to subtract 3s from both sides, and that gives me u is equal to 1 million. I'm just going to say 1 million minus 3s. And I'm going to substitute that in. So this is u is equal to that. So I'm going to substitute that in for u here. So I got 0.145s plus 0.04u, which is 1 million, minus 3s, and that's equal to 45,500. So 0.145s plus 0.04 times 1 million is going to be 4, and then 4 zeros. So that's not 0.4, this is 4. And then 0.04 times 3 is going to be 1.2, so minus 1.2s. Wait, 0.04 times 3 is 12, it's 0.12s, pardon me. So 0.12s, and that's going to be equal to 45,500. I'm going to combine like terms. If you add those two together, you get 0.025s is equal to 45,500 minus 40,000 is going to leave you with 5,500. If you do 5,500 divided by 0.025, it's the same thing as 1, 2, 3, add 3 zeros, get rid of that. 25 goes into 55 twice, and then it goes into the next one twice also, and then you have 1, 2, 3, 4 zeros left. So 1 and 3 more zeros. So $220,000 is the answer. $220,000 is equal to S. So that's what went in S, your short-term notes. Twice as much went in government bonds, that's 44 with a bunch of zeros. And then the rest went into utility bonds. So this is 60, so that's 340,000 went into utility bonds. 34 plus 22 plus 44 equals 100, or 1 million. So 100 thousands. So this is the amount that you should get for each one.